Okay, so let's explain what the hell we're trying to do here. So first of all, let's make a note, right? The video integer ID right now is 209. And the time is 0028, and let's call it 50. That's a 28 and a 50. Okay, so we're going to have some different selection debug modes for this object here. And we're going to say that, you know, off, no debug happening, right? Alright, so no debug happening, right? If it's all, inset, slightly shrink all of the cutter rectangles and render them all at the same time. Then intersect with profile geometry to get an idea of how the entire model will be cut up, right? So for the all, that's what we're gonna do, right? Okay, so the other thing is for selection, same idea as all, but only the selected grid rectangles will be rendered rather than the entire grid, right? So we're going to try to overlay a grid over the geometry we've made and slice it up into pieces that we can then bolt together later. And in order to do that effectively, we need some debug modes for this to understand better what we're doing. Now let's make sure we haven't introduced any syntax errors while we've been thinking this out. Okay, good. So for the configuration, what we're going to do is we're going to have this profile object is going to take a object called GOC, right? And GOC is going to be grid of cutters, and we're going to define an overlaying grid that goes over the entire model, right? So this grid is going to need to be centered, right? We're going to assume the grid is completely centered, and that the grid has a number of cells on the X, number of cells on the Y, and the grid has an Imperial Span, and this is the, this span, I was thinking that this would be for each cell, right? We want to know, the important thing we want to know is, like, how big is each cell? Because when we're trying to get parts for the shopbot or a laser cutter or something like that, it's the actual part size that we care about, right? We don't care about the gestalt of how big is this entire grid, right? That doesn't affect us. What affects us most is the size of an individual cell, because that'll create the bounds of the part that we're cutting out, and that bounds is kind of important to us. So so this here is of one cell, right? So cell Imperial Span. So SCA is selected cells XY array. So this is going to be a list of all the cells in terms of XY. And then this is going to be the number of selected cells. So basically this is the array and this is the length of the array, right? So now we might want to make this a little less terse, right? So because this is a lot to, right, like bug mode selected cell subcomponent index, selected cell, right? So this is the selected component from here, and this is the selected cell. So I'm not sure if I really like this yet, because this makes it look like it doesn't go together, right? Because this is the array, and this is basically the length of the array, right? But when we're selecting this, we want to make it really easy to just be able to say, to just make this a variable and make this a variable, right? So if we just call it array and we call it length, that's a very generic thing, and also length is a keyword, so that also creates a problem. So this bug mode, selected bug mode, right? Selected debug mode. Bug mod, right? Off, all, and selected, right? We want to call it like SBM, right? So selected bug mode off, selected bug mode all, right? Something like that. And then we could call this, we could try to make this more uniform, right? So this could be SBM, right? SBM, I don't know. Or so we have dex here, right? We've been doing this dex as the second parameter. So selected debug mode. I don't know. Well, actually, if this is cell dex, if this is cell dex bug mod right here, then maybe what we want is to have it like this, right? So that these match, right? So we could do this. So cell dex bug mod. But that doesn't match. This is not matching. Why is this not matching? Oh, so when match case is turned on, it automatically doesn't token highlight like that? Is that how that works? Oh, now. Okay, now it matched. Okay, yeah. So what we could do is, if we want to know the connection between here and here, then maybe this gets a little bit different treatment, right? Celldex bug mod, so it kind of matches, right? I don't know. But we definitely want this kind of debug mode. Okay. And so this thing here, now we could expand this a bit, right? We could be like this. We could go number of cells. Width. Number of cells. The width. Number of... So, number of cells width and number of cells height, right? Knock width. And if we do that, things get a little bit bigger, but then we know what we're doing, right? So so this could be the profile. This could be the profile subcomponent index, right? And this is the selected subcomponent index, right? So this tells us what we actually want to render in here. does this object need to be in here, or do we just really need the selected subcomponent index, right? Because the profile... like, this is just a configuration object to figure out how to slice it up, right? So this thing doesn't seem like it should be here, right? It's, right, it's a selected subcomponent index within the actual profile, right? So when we have multiple things, if we need to render only one of them in order to cut things up correctly, right? So as we're cutting things up, so hold on. So I think that this actually has to, we're going to nuke this. And I think that the structure of these selected subcomponents can tell us what to render, right? Okay, well that creates a problem because if we try to render everything, then we're gonna have a problem because we're gonna loop through this stuff, and if this selects the subcomponent index, then we may or may not have. We can't really do this in a loop, can we? Well, we could call this. Yeah, this is going to tell us what subcomponent to make visible, and this is going to tell us how to slice it, what slice we're going to take. And if we're debugging, right, if we have this debug mode turned on, if the debug mode is turned on, right, we can just make all the subcomponents visible and we slice it all. Okay. So the cell Imperial Span, right? So cell imp, right? Selected cells XY array. So cell selected, right? Or cell array, right? It's an array of cell data. And then cell len, right? Cell, so these are selected, so we have the cell size. This is the selected array and the selected length. No, this is, yeah, because these are all these selections, right? And now down here is this is the array of selections. Here is the length of those selections, and then down here, what we're doing is we want to know what piece of geometry, We want to know about the subcomponent index to render. Okay. So we could call it cell sub, right? Cell subcomponent index, and then selected cell could be selected dex, right? So this is the selected subcomponent, and here's the selected dex of the current cell that we want to render, right? So something like that. Something like that. And then, so we have a selection array and a selection length, right? And we can use the cell dex into there, right? So I'm thinking instead of calling it a subcomponent, we call it a subcomponent. Seems kind of confusing. So geo, right? Like it's the subgeometry of the profile, like a geo index, right? I don't know. I know we already have this thing called geo indexes, but subcomponent index, right? It's the geometry, right? So we might want to start labeling some of these things. And just say let's just make an so this is selected cells XY, right? This is an array of XY locations, and the XY locations are in terms of cell coordinates, right? So it's in terms of this number of cells on the width and the height, right? This is the thickness of a single cell. This is the selections, right? So we're not going to select the entire grid, right? We're going to create a list of cells to select, right? And then also, we want to create we're overlaying a grid, right? When we're overlaying a grid, there's two grids we actually want to overlay, right? So we want, there's two grids, right? There's two grids we need to overlay to chop things up in a way that's going to be suitable, I think. And each grid has to be offset relative to the other, like with a 50% offset. So it's like, so let's say this is, let's do this first grid, right? So we have this grid, and then, right, no offset. Okay. And then we need another grid that is, if this is the original grid, we need another grid that is, where the midpoints, where the lines of the grid go between these things here. But I'm not sure exactly how that needs to be done yet. But we know that eventually we gotta chop it up a little bit more than it's already chopped up, is what I'm saying. But I'm not sure exactly how, right, how we're gonna define that, because we gotta chop it up, and then we have to, if we're gonna bolt together pieces, well, the pieces have to straddle each other, right? Otherwise, we have nothing to bolt together. So, is this the best way to chop things up, or are we just overcomplicating the problem? Do we just have to bite the bullet and figure out, a better way to chop this up? I don't know. Because for the current model, we could just do a vertical slices of certain thicknesses, and then we could interlace those vertical slices and then something. Like, that might be the easiest way just because of how this is. And then to make sure those vertical slices can fuse together, yeah, I don't know. I don't know what the best way to partition this problem is. Like, there has to be a way to partition this problem so that we can just slice it, right? We just want to slice it up somehow. But we want to slice it up in a manageable way that's kind of easy to work with. So, I don't know what the answer to that is. We could create some type of maybe partitioning it into cells is not the best way, right? Maybe what we need to do is we need to create like a slice chain. All right, so maybe what we need to do is, so let's make sure that we haven't introduced any problems here. So, because we're guessing around here, so let's save this, make sure that we haven't corrupted the syntax. Okay, so maybe we need a slice chain. Maybe we need just little points, right? We have points around, we just locate different points, right? Instead of a grid, we create like a little chain of points of interest, right? We kind of trace this. We do a little connect the dots between some points, and then with those points, we can create little capsules, right? We can create little capsules to cut it, right? And we can try to space them out in a way that kind of makes sense. And then the capsules themselves, as we're trying to render it, right? So we create a line segment, and then we convert that line segment into a box, right? And if we have a point from here to here, right, and we have a line segments, we could cut normal to the lines, perpendiculars. Or we could cut vertically or horizontally, right? We could naturally cut horizontally. But then how do we control which direction to cut, right? Because we want to make some crossbars here. So how do we know if a vertex is which way a vertex is supposed to cut, right? So it'd be nice just to create like a selection geometry around here, right? Just create like trace this with a polygon selection, and then divvy up that polygon somehow, right? I think that might be the easiest way, but I don't know how we would do that, right? But we could, if we if we create a whole bunch of polygons, right? So we just create the polygons, but now we have to manage those polygons and make sure they're like adjacent to each other and whatnot. I don't know. I don't know how to fix this. If we just try to make a grid, there's going to be all sorts of times when this shape, which is curved, is just not going to cut well with that grid, right? We try to define some type of uniform size for the grid cells, And we're going to run into cases where that size just doesn't work out for us for whatever reason, right? And we can already try to get some tracing points on here, right? To figure out where to cut it. And once we have those points, if the capsule that we create isn't too egregiously big, then we don't even have to say render either this or render either this shape. We can just render the whole shape, and we can trace the path with something, and then take two vertices on that path and create a cutting shape, and then we could also inset that cutting shape by a certain amount, right? Like if we know we need a gap somewhere, we could create gaps, right? And we could say, we could just configure it to have a, so as we're cutting the shape, I'm thinking we always make the lines vertical or horizontal, depending on whatever fits best. And from that, like if we have a polygon here, right? We have a polygon here, and we have a little vertex here, right? Because we're trying to trace this. Then what happens out here? How do we slice this? Well, first of all, we probably shouldn't slice that. We shouldn't slice that, right? Because we should slice it like here and here. So maybe we can select more than one vertex, right? You can select vertex 1, 2, and 3, right? There's a vertex selection, and from that vertex selection, we can just build a shape from it, right? And to dynamically loop through vertices is difficult, right? So we just preset to say, you know, we can either select 2 vertices, or in some cases, maybe we can select 3 vertices, right? So we just hard-code it to select either 2 vertices or 3 vertices to make the selection, right? So if we want to select from here, here, and here, we can have a list of vertices, and then we can build an intersection shape properly, and then we have it cut, right? And then when we want to cut this differently, right? We want to cut, like, instead of chopping here, we want to chop here and here, right? So we would need two shapes, 2 versions of the same cutting path somehow, I think. Right? Like, it would get kind of complicated, right? It's kind of complicated, so we should probably just not. We should probably... We're trying to make some type of automated process to, like, carve this up. And I think that we're getting too complicated. So, I'm thinking that this idea, cutting things, cutting things with a regular grid seems a bit likely to fail, because we will probably end up sometimes having... sometimes we're gonna end up having parts that don't align well with grid. Thought about tracing parts with a polygon line with a connect the dots polyline. I guess it's a polyline, yeah. It'd be a polyline. And then generating selection areas from groups of 2 or 3 selected vertexes. So it's a lot of work. Let's say this, right? Yeah. So, 1. Hard to create data set. And 2, it's hard to process the data set. It's hard to create the polyline data set, and then it's also hard to process polyline data set, right? There's 2 things that just make this a little bit too hard, and a little bit too like it seems like a good idea, but then when you think about how we would have to implement this, it's like maybe it's just a bad idea, right? Maybe this is just a little bit too crazy of a notion. So even though we're thinking out variable names and we're thinking about what we want to do here, I don't see it as a good idea. I think that, and also let's just make these contiguous. Like, we're probably not going to do it, but let's not keep it a complete disaster, right? So yeah, this idea here. Where the hell are our other variables? We're missing our other variables. God damn it. It's a bad idea. And at some point, we have lost the other variables we were making. Have we not? Oh wait, no. GOC and CellDex have been merged together. Oh, well, maybe that's why the numbers weren't contiguous. Yeah, that would probably be why the numbers weren't contiguous now, wouldn't it be? Okay. So this is GOC. And this thing here is cell, right? Yeah, so this is just an idea, but now that I think about it, I'm like, no. Okay, so if we look at this F4, let's make sure that we haven't screwed it up yet. So what I'm thinking is we just have to go in here and we have to just start cutting away, right? So we got to configure it. We just got to give it like a cutting rectangle, some cutting rectangles, and just manually define some cutting rectangles or cutting polygons. And just start slicing and dicing it, right? So we're just going to have to start meticulously creating some way to slice and dice this up. I'm thinking that I want like 2 rings in here, right? So I want like a little section right here and a section. It could be right in the middle if we wanted it to be. But that would be the hardest option, right? Having it in the middle, because of how we want to just slice this up into symmetric pieces. But even though we're gonna have to have pieces cross. God damn, this is hard. But we gotta chop it. We gotta chop it into pieces. And once we have it chopped into pieces, we have to center those pieces. So we could just start figuring out where we want bolts. Where do we want the bolts? Right? How is this going to bolt together, right? And if we figure out where it bolts together, right? If we figure out where the bolted sections are, I don't know. I don't know how to do this. This is too hard. Well, it's not too hard. I mean, I'll figure it out. It's just that I gotta think about the implications here. It's very tempting just to be like, oh, we can just slice it with some rectangles and be done with it, right? Well, what's the most flexible way? The most flexible way is that polygon idea, right? The tracing this with a polygon, right? It's going to take some time to, like, plot some points on here and make sure those points are kind of dynamic. But once we have those points cut, we can calculate distances along the path, right? We can say... we have to create a polygon where you can slice it like on the... you can do an odd-even alternation, right? So we have like a point here, and then we have a point here, and we have a point here. And you can slice it here or here on the... so let's say we have a point here, point here, point here, point here, point here, right? So even, odd, right? And sometimes we want to slice only on the evens, right? And then we want to create the kind of similar kind of deal. We do the same thing, but on the odds, right? Now, the problem is we don't want to slice in the middle, though, do we? We want to slice... how does this go together? Here, and then... well, we slice here on the junctions here, then we also have to make... and that's not a bad way to do it, it's just... as long as we have something to hold that together. Yeah, so odd-even slices. Odd-even slices would be good, right? So we slice in odd evens, and that'll help us... okay, so we slice in odd evens, and then the thing we want to supply to the, now, how do we handle this, right? We're going across here. How do we know how far to go here, right? Do we, right, because we're going to need something that spans this, right? So we have the final point, like, right over here, right? And it's kind of symmetrical. Or this last point here. Okay, so maybe we have like a last point on the midline, right? So we want to put some dots here, right? And this is all redundant, right? So the last dot we want is right here. And then we just have to understand that it's mirrored on the XY axis. No, because not all the parts aren't always going to be mirrored, right? The parts aren't always going to be mirrored. So I don't know if that's a good idea. Well, maybe. Okay, so the parts aren't always going to be mirrored. So we could mirror, but just because the parts aren't always going to be mirrored, so we want some type of process that works if the part isn't mirrored. So the actual mirroring could be in the data set. So the data set for all these points that we're going to trace, we could actually mirror that data set. And then, you know, select here and here. We select across the boundaries at one point to create our selection rectangle, and then other times we don't, right? And then certain points of interest, right? Certain points, like if we want a crossbar here, then that intersection point, that vertex could be labeled, could be given an attribute number that says it's a crossbar vertex, right? It could be given it could be given an attribute, right? So so we have basically an array of three-dimensional points, right? It's the XY of the vertex, but then it's also some type of attribute that tells us what that vertex is responsible for, what it does. Okay, I think that is actually the way to go. I think that's actually the way to go. So, so what we're thinking is, so we're going to have like a polyline, and that polyline is going to be embedded into the function, right? We're not going to have a separate polyline that's separate because all the variables we need to create that polyline are already in there, right? So we need something like a polyline selection, right? Polyline selection. So how do we grab it? How do we grab what we're looking at? How do we grab what we're looking at? So okay, we create that polyline. We do segments, and the segments can either be even or odd, right? It's a segment index, and we can do an even or odd segment. And okay, even or odd segment that we want to grab an even or odd segment, right? Okay. And where do we store the data for how these vertexes might be kind of special? Well, when we're selecting a segment, a segment selection, we just want to know what segment, right? So we have this profile, and then we have a certain segment that we want to grab, right? So we want a segment, and so we want like a segment index. But then we also want to know whether it is if it's an odd segment or an even segment, because the segments have to be, if we're going to bolt this together, the segments have to be kind of like interlaced, right? Okay, so we have like the segments, which kind of segment it is, and then if we have a vertice point here, if we grab a segment from here, so we have a point here, a segment, another segment point here, and then a segment point here, and this point here is saying, oh, I'm special because I want a crossbar here, so we need to back off here. So we just say, oh, special segment, and then we just back off, right? So if we select this segment and the last vertex is a special segment point, we back off of it. Yes. Okay, so we just want a segment index. And we need to know the number of segments, right? So when we're giving this kind of payload, the payload itself knows what segment it wants to select. Okay, so so I'm thinking maybe something like this. We call it seg, and we have like a segdex. Segdex bad equals, 0. Okay, we have segdex number of segments. Number of verts. Okay. Number of verts, not segs. So we want a number of verts, which just tells us if we're out. If we try to select a segment index that is invalid, the number of verts tells us if we're out of bounds. Okay. So we need the number of verts, and then we're going to do a segment index. And why does the configuration object know this, right? Well, the reason that we need a configuration object with this is so, okay, if we want to loop through all these parts, how are we going to do that? Well, we need to know the maximum segment index, right? We need to know, and if we need to loop through the maximum segment index, we have to somehow keep track of that, right? So if we have one object that has that all in there, we can manipulate that, right? So we'd have to create a copy of this object to change what the segment selection is. That is kind of ugly, isn't it? So making the segment array right, so this object, it's passed in as a configuration object, but this object has to this configuration object, this number of verts just has to match internally what is actually there. So it's kind of like self-declaring. Yeah, that's kind of weird. Okay, so this configuration object is just going to be weird, right? It's like we have a lot of constraints. We just have to do something that works, right? So it may be kind of weird with how things get passed around, but I guess it's a hack, and we just got to get to work. So we have the number of verts, right, not segments. And then we have segdex selected, right? So this array object, this is some type of configuration object that we're going to have to mutate, aren't we? So we pass in a selection, and the selection. Why does this object both have to declare how many segments there are and what the current selection is? Well, unless we want to pass around two objects, right? A thing that says how many verts there are, which is just weird to have just that one piece of information. Then we have to do it this way, right? Do we really want to have a separate parallel segments array outside of the profile function that tells us how the data is cut up into segments? I don't think we do. So I think we want something like this. Okay, yeah. So the selection is the actual index of a segment. Index of segment. And this tells us if it's like a odd or even straddle. Okay, so even straddle, right? So even takes 0, takes something like this, right? Odd, an odd would be 1, right? When we're taking segments, it would be like this. Between these, right, between these, how can we diagram this in a way that makes sense, right? So here's even 1. Here's odd. Here's odd 1. So here's the first odd, right? So what's next? What comes after that, right? So if we're doing the next even 1, it's going to move to the 2, right? So we go from here to here, and they're going to be contiguous. So this is going to be 2, 3, and 4, right? And the odd, so if this is the first odd, the second odd is also going to be contiguous, right? So this is going to be 3, 4, and 5, right? So we have this overlap. You see this overlap? So even 1, odd 1, right? So we kind of connect like that. And so, so odd or even tells us, are we taking these, right? If we're even, we take these. We take this, we take this. So we take everything always in pairs of three vertexes, right? And then over here, for the odds, right, we select like this, right? And then different vertexes within our data can have a configuration that gives them special properties like these. So yeah, okay, this could work. This could work. Okay, I like this. This could work. So at vid IID 0209, time is 1 hour, 23 minutes, and let's just make that let's wait for 2323 just because that amuses me. This scheme might just work. Right, so this scheme might just work right here. So this right here, right? We're going to give it a segment object. That segment object will have a few entries in it. It'll be an array. The first entry in the array is not used, right? It's a bad index. The next element in the array is the number of verts, not segments. So the number of actual verts. So here in this diagram we have 5 verts, or actually no, we have 6 verts because this is 0 and this would be the 6th vert. So the number of verts, we declare the number of verts ahead of time. So we pass in this object, this seg object that knows the number of verts inside the function, which that is batshit crazy. That's weird. But if we want to procedurally loop through this with just knowing the segment object, we'll have to do it that way. That's just a reality of this functional language. This selection here is the index of the segment, not vert. So it's not the vert. It's not the vert. So it's the index of the segment, not the vert. Right? So the number of verts, the selected segment index, and then odd or even, right? So these are even segments. So this is segment index 0, this is segment index 1, right? This is also segment index 0 and segment index 1. The only thing difference is that this is segment index 0 when the odd or even is set to even, right? So this will be a 0. And then when we're on odds, segment index 0 is this. Okay, that makes sense. I like it. It's I think that is the best way to do this. It kind of sucks that chopping this up is kind of complicated. But I think this is going to be the best way to do it. I think that of all the ways, right? So we have to, right now that we've created the profile geometry, we have to actually now kind of go through it and meticulously chop it up into segments. So because this is mirrored, right? Because this is mirrored right here, we will have to painstakingly go through here and define these as well. But I'm thinking we could also how do we know how many parts we need, right? We need a convention for okay, one thing at a time. Okay, so we have the idea for how we're going to cut this up. So we just need to cut it up. And we really only need to cut up to here, right? So how are we going to deal with the fact that this mirrors around here? And do we really want to... How do we deal with that? Well, we just have to make sure that we have a segment here. We have a vertex here, a vertex on the midline, and a vertex here. And so we can take a segment here. So all we have to do is mirror. So we have to have a selection right here on the midline. And then we have one that just goes across. And this one that goes across needs to be a mirror of this point right here, right? And if we do that, then we don't have to trace all of this. We just have to figure out the mirroring for just one point, right? So everything else you don't have to worry about. We just have to figure out the mirroring for one point, right? And then we start to trace this, right? So this can be on the same. Ooh, okay, hold on. So this is a different line segment than this, right? They're not connected. Now, we can either define a profile, a different profile for this. Like, here's this line segment, here's this line segment. I'm saying that the line segment index and the profile index can be the same thing, right? So the segment, or the selected line, the line index, right? The polyline index can match up with the geometry that we need to render. So we have the number of verts, the selected index, and then more general than the number of verts is just, well, what polyline is it, right? So we need a thing called segdex, and we need the polyline index, or polyline and polyline and geometry index, PAG. Polyline and geometry, and so this thing could be segdex, odd eve. Let's make this a little bit bigger, right? So let's make this odd eve for odd even. This is segdex. This is number of verts, right? Num verts, segdex, odd and even, right? And then this is going to be we could call it lin geo. Or we call it geodex. Geodex. Geoline, right? And that it's both the it's the geodex plus the lindex, right? So 1, right? And that's geodex equals lindex, right? So the line index and the geometry index are always equivalent to each other, right? So there's a line number 0 is this line, and it's also geometry. So this is geometry number 0, and it's also line number 0. This right here is geometry 1, and it's also line number 1, right? Like a 1-to-1 pairing there. So we call it geoline, right? Geolin. This is the number of verts, not the number of segments. This is the segment index, and this is the odd even, right? So I don't know if it needs to be odd even or even odd right now. Even, we start on evens, right? Because we start at 0, so I think it could be like eve odd might make more sense, right? And I don't think, so if we go odd eve, or eve odd, we don't have any shortcut for that yet. So let's go over here and just start to document some of these things, right? So, so we thought about it for a while, and so let's just document each one of these things. I'm gonna turn the music back on and just do this. Okay, so we're gonna try not to, I know we haven't been doing our push-ups, but our little message for last chance to lift weights kind of went off. So what I'm thinking is, you know, just because we can't be perfect, just because we can't be perfect doesn't mean that, just because we can't be perfect doesn't mean that we can't at least do something, right? So we're going to take a break, and we're going to do our push-ups. We're not going to do all our push-ups. We're just going to do like 30 push-ups, just enough to where we got a little bit of exercise in. Not all of it, but let's let's look at our thing, right? So push-ups. What is today? Today is Tuesday, right? So Tuesday, let's just do 30 push-ups and call it a right. Let's just take a break. Let's do a 10-minute break, red timer. And we're just gonna give it we'll give it 10 minutes. We'll heat up our coffee, and we'll also do our push-ups and things while we're heating up our coffee, and then we'll come back, right? And whatever amount of push-ups we get done, we get done. Okay, I'll be back. 26, 27, 28, 29, 30, 31. Actually, it's beautiful. Let's do this right. Okay. So, we got 31 done, right? Now, it's not exactly what we wanted, but we're just going to have to say we... Okay, we're going to keep on, so we think we got a good way to approach this problem, even though it's taken us way too long to think about this. But you know what, right, it's a new type of problem, and I think this will work. So, we're going to have to start by, taking this object here, and we got to separate the rendering code from the display code. So this thing here, we said this thing is going to take just a profile object, right? It's going to take a profile object, and the profile object, this thought here, we're going to nuke that. Let's forget about that. So it takes the profile object, and the profile object needs to know about a lot of stuff. So zitpro do we call it zitpro, or do we want to call it seg, right? This is called seg right here, right? So we'll call this zitseg. We'll get a segment object. So zitseg symmetric legs. And this will be the base object, right? So the base object, we're just going to say, we're going to take all this stuff here, right? So we're going to take this, these things here. We're going to take these, copy them. We're going to use them to annotate this. And this has to be oh, you know what? This needs to be changed around a little bit now that I see this. So let's comment this out for a second. So we have the number of vertices, then we have the segment index. So this actually needs to be up here, and you're going to see why in a second. So we have the number of vertices, and then we have the number of verts, and then we have segdex, number of profiles and lines, or number of profiles, number of vertexes, and number of profiles. Well, actually, can't this thing know? We want to be able to loop through it, so we want to go. We want to know the number of segments, right? Which is also the number of the number of verts, I guess, would need to have a. Okay, if we're gonna do it this way, right? Oh, this isn't even correct. Number of, the number of lines and the number of vertexes, right? So here we're going to, selected line so might make more sense like this, right? So this is just because now it's kind of more homogeneous, right? We have the numbers and then we have the selected, right? So we have the number of lines, the number of vertexes, and we select a segment. But then we also want to know if it's even or odd, right? Something like that. Number of lines / geoms. And this is number of verts, okay? And then selected so this is the selected index. Line segment. And the line segment is 3 vertexes. 3 vertexes per segment. Actually, no, this is selected line so this is number of lines / geometry. The selected segment is not a selected vertex, right? So this is the selected dex of 3 vert of a 3 vert segment, right? Keep on changing our mind here. So, so in the code here, where we kind of like we keep on changing our mind here. Instead of geoline, right? Geoline means Right, that's what GLN means. Use, right? So I'm thinking this could be numlin. If we do this linnum, so I'm not sure about this, right? If we do this number of lines like this, yeah, so we're saying numlin instead. We're saying glin is too complicated. The number of vertexes is still okay. The seg dex selected segment. Okay. Also good. We're just gonna say, you know what, this is okay, segdex, but cell seg is also okay. Oh, I see. So cell seg, and then the selected line, right? So the next thing we want is the selected line. So we got the number of lines. So numlin means what? Numlin means, and numlin means, and numlin means. Number of polylines. See sbf.scad. Something like that. Okay, so let's try to reload our shortcuts because we obviously are confused about how we want to do this still. So let's reload this, make sure that all this kind of works. Because we're making up a whole bunch of variable names. And after we're confident that works, we'll start to refactor this a little bit more. But right now, we need to make sure this works. So I'm going to put this over on the other screen. And hopefully we won't have any collisions. And if we do, we can fix them, right? So f vernum. Okay, that's fixed. Okay, let's reload this. And then we're just going to trace this, right? We're going to put some points in here, and we know we need this kind of odd even pattern because we're going to segment it up into pieces. But we're getting pretty close to how we want to do this. It's been kind of painstaking here, but we're figuring it out very slowly in terms of how we want to break this up into pieces. So, yeah. So we might want to say change this. We want to stop the stream and rename this because it's not really grid of cutters. It's going to be like cutting. Yeah, let's stop the stream and rename the stream, right? Let's stop this because I want to do a time lapse of this, so I might want to change the name, right? So I'm going to do that. I'm going to stop streaming, change the name, and call this something else.